Welcome back, guys. I'm so happy that you came back to see a little bit more on matrices. Just hold on. Well, we're almost at that finish line. We're going to learn how to solve our system of equations, but not there yet. For today's session, we'll be looking at how to find the inverse of a matrix using the row reduction method. There are several ways you can find the inverse of a matrix, but this one just focuses on using the row reduction method. And I just wanted to highlight last session, if you guys can recall, echelon form is the form where you have your leading diagonal containing ones, as well as you have all elements below that leading diagonal consisting of zeros. Okay, so that was our last lesson. So today we're going to be moving on to finding the inverse of a particular matrix using row reduction. So allow me to introduce you guys to, drumroll please, the augmented matrix. Not demented in any way, but augmented. Now, an augmented matrix is a matrix formed by joining, right? We're going to join the columns of two matrices. So let's just say, for example, we had the matrix 2, 3, 4, 1, 1, 1, 0, 5, 7, and we're calling this matrix A. And then you had a second matrix B, 2, 5, 0, and we wanted to augment these two matrices, aka join them up, such that we get A augment B. This is the symbol for augmentation. All right, that's our symbol there. That's the Y, guys. All right. Upon augmenting these two matrices, aka joining them, this is what the fully joined matrix looks like. We would carry that symbolic sign of augmentation along within our matrix, and we simply rewrite the first matrix before our augment symbol. Very nice, very simple, and we would write our second matrix after our augment sign in that particular order. So very easy, very simple. It's not difficult at all. And that's about as much as you need to know about matrix augmentation. Now, how is this relevant to finding the inverse of a matrix? Well, let me show you by example, shall I? So let's consider the matrix A. All right, so let's just say we had a matrix A having values 1, -1, 2, 2, 3, 1, and 1, 2, 4. And they are asking us to find A inverse. Now, you guys know from my previous videos, there's a method where you can use, there's a formula, and it's a long process, and you can go ahead and find A inverse. But if they say to find A inverse using row reduction, then we need to follow instructions. And in order to use row reduction to find the inverse of a matrix, you need to create an augmented matrix with the identity matrix. So first point to note is that to find the inverse of any matrix using row reduction, we first must augment the matrix A with the identity matrix, or with its identity matrix. All right, so pretty much in a nutshell, what we want to find is we want to augment A with the identity matrix, and then through a series of row reductions, we are going to try our very best to achieve the identity matrix on the left-hand side, and then whatever we get as a result on the right-hand side ends up being our inverse. Okay, so this is the essential key towards finding the inverse of a matrix via the process of row reduction. You must always augment your original matrix with the identity matrix. Let's look at an example. Okay, so we're going to scroll up here. Try our best to leave that a bit on screen. And we are going to look at the matrix. Well, we have the matrix A above. So the first step we are going to do is to augment that matrix 1, negative 1, 2, 2, 3, 1, and 1, 2, 4. We're going to augment it with the identity matrix, guys. And I hope you may have recalled what the identity matrix looks like. It's when you have your leading diagonal being all zeros and values below and above. Sorry, your leading diagonal being all ones. The zeros caught my eye. And your values above and below your diagonal, all zeros. Cool. Now, I don't want you guys to confuse this with echelon form. Echelon form really considers values below your leading diagonal being 0, not the values above. Okay, so this is the identity matrix here. All right, guys. And now what you're going to do is you are really essentially row reducing with consideration of your matrix on your left, which is your A matrix. And you are really working very, very strategically hard towards achieving the identity matrix on that side. And you're not so much concerned about what's happening here. I mean, you perform your row reductions horizontally across equally, doing whatever you do to both sides of that augment sign must be done throughout your full row. However, your focus should always be on your before your augmented sign in terms of what am I going to do to achieve 1 in my diagonal? What am I going to do to achieve zeros in my diagonal, etc. Okay, so now that you know where your focus should be on, let's get into it. And because we already did a video on row reduction, I am going to move just a bit rather quickly by simply doing the first 2 steps I would have taken, and then we'll get into the answer. All right, so looking at row 2, we are going to try to attempt to reduce row 2 by adding row 2 to row 1. And in doing so, we end up getting row 2 plus row 1 gives us automatically, I'm going to do it on screen, 1 plus negative 1 gives us 0, 2 plus 3 gives us 5, and finally 2 plus 1 gives us 3. Okay, so that's our new row 2. And similarly, I'm also going to attempt to reduce the third row using row 3, subtract 2 row 1. And row 3, subtract 2 row 1, I think I'm going to have to write this one out. That's 214, subtract 2 times row 1, 1, 2, 1. That's going to give us 214, subtract 2, 2 2s are 4, 1 by 2 is 2, and that gives us 0, negative 3, and 2. There we go. So now we are going to rewrite we are going to rewrite our new matrix using these new rows. So we have not done anything to our first row. So our first row remains the same. And our second row has now become 0, 5, 3. And our third row has now become 0, negative 3, 2. Now notice I closed my brackets here, and that's because I forgot that we are doing an augmented matrix. So please don't do that in exams. Remember that you have to perform what you do on your left to your right hand side. So as well, to row 2, I will augment on both sides. I will augment to remember that adding row 2 to row 1 on the right hand side, that identity matrix will give us as well 1, 1, 0. So you would get 1, 1, 0 here as well. Sorry, we did not get 1, 1, 0 here because we were affecting row 2, not row 1. And then finally, attempting to take row 3, which is this one here, which is 0, 0, 1, and subtracting twice row 1. Twice row 1 would be 2, 0, 0. We would end up getting 0 subtract 2, that's negative 2. 0 subtract 0, that's 0. And 1 subtract 0 gives us 1. So after a successful row reduction, you should have gotten the following values you see on screen, and then we shall move forward. So what we're going to do next is we're going to try to change that second row. So you can see that the identity matrices are beginning to form on the left-hand side. So we're going to take row 2 and we're going to attempt to find 1/5. So we're going to try to get that diagonal of in row 2 to become a 1 here. And as well, we are also going to attempt to find negative 1/3 of row 3 so that we can get a 1 here as well. It makes it easier to work with. In doing that, what we're going to end up getting is, so I'll write out my matrix here. Matrix, the row 1 will remain as is because we are not performing any row reductions to affect the first row. Row 2 changes to 1/5 straight across. So that will give us 0, 1, 3 on 5, 1 over 5, 1 over 5, and 0. And then finally, negative 1/3 of row 3 gives us 0, 1, negative 2/3, and on the right hand side we'll get 2/3, 0, and negative 1/3. All right, guys, so this will keep going on and on and on, and you'll have to perform a couple of row operations. I'll just state the row operations that are necessary to reduce this one. They will be row 1, subtract row 2, then you can take row 3, and you can attempt to take row 3 and then subtract row 2, and then that gives you 1, 0, 0, 0, 1, 0, negative 1/5. That'll give us 3/5. I am not working these in my head. I'm not that good, guys. I have some pre-work solutions over here that I am just simply choosing to rewrite. Let me write this clearly for you guys to see. There we go. And on the right hand side, we will get 3/5, negative 2/5, 0, along with 1/5, 1/5, 0, and then 7/15, negative 1 over 5, and negative 1 over 3. So guys, this process is highly, I wouldn't say repetitive, but it's highly of a calculative nature, where it just involves you being able to multiply and divide very carefully So it's not so matrix heavy if you think about it. And I am not about testing so much on calculators today. So I'll just tell you guys that at the end of the day, once you perform your row reduction steps very carefully and properly, what happens is that eventually this matrix, when you row reduce your left-hand side to become that identity matrix you are trying so hard to develop, the values on the right-hand side actually turn out to be 10 over 19, negative 7 over 19, 1 over 19, 8 over 19, negative 7 over 19, 2 over 19. You can take these values and you can try on your own and you can see if you got these values correct. If you did, congratulations on doing a great job of making minimal mistakes and errors. So you should end up with something like this. And please do recall that from before, we started off with our matrix being augmented with the identity matrix. And after a series of row reductions, what's happening is that we got the identity matrix on the opposing side, and whatever is left on your right-hand side is actually your inverse. So your answer for the inverse of the matrix is finally this matrix on your right-hand side, and you can simply state out your values. You could also factor out that 1 over 19, and you can write down your values that are left so that your matrix looks nice and cleaned up like this. Okay, guys, so this would be your answer. So it's a tedious process, but then so is finding cofactors of a matrix and the adjoint of a matrix. The methods for finding the inverse of a 3 by 3 matrix are all long, but they are all simple. And whichever method you choose to familiarize yourself with more or choose to work with, that's absolutely fine, unless, of course, your question specifies that you have to use this particular method, because perhaps they want to see your skill level at being able to apply that method to a question, guys. So it's a nice one. I hope you guys were able to follow along as I was working. And of course, if you would like to see a full worksheet on this where I start from beginning to end with absolutely no break in between, step by step, no steps missed as I did in this session. Remember, these sessions are just meant to explain the concept of the topic and not so much doing lots and lots of examples, because, you know, we do have that limited time frame where students tend to click end video when it's too long. So I like to break up my sessions into tutorial sessions or conceptual sessions. So guys, if you have any comments, if you would like to see tutorials, make sure to like and comment below. And I appreciate you watching my videos every time, all the time. And I hope you guys come back soon for more. And hopefully we'll be able to finish matrices within the next 2 videos, guys. Okay, bye. Take care and all the best.